Welcome back, everybody. Welcome back to my math channel online today. In this lesson today, I would like to talk about the new unit, which is polynomial function in the Recalculus Math 12. So in this polynomial function, you will learn about how to devise the algebraic expression using the long division as well as synthetic division. Also, you will learn about factor theorem and remainder theorem, and various problem solving involving the polynomial function. So let's get started. On the board, I have a question. I'm missing it. Let's say recall. If we have to divide a number 335, divide by 7. Now, in the elementary school, everybody know how to divide this number. But just let it refresh. So let's see how we will divide this number. Now I'm going to copy down 935 here, and I put in the division number 7 here. So when we divide, it means we try to find a number times with the number 7 here equal this 935 number. However, because this is a single number and this is a 100 number, so based on this unit, we only pick the number 9, we divide first. So 9 divided by 7 will be equal 1. 1 times 7 equals 7. That is the closest we can get to closer to the number 9 as much as we can. And we subtract. So 9 minus 7 gives us 2. So we're going to bring down the 3 again. And now we have 23 divided by 7. So 23 divided by 7 equals 3. Because 3 times 7 equals 21. That is the closest number we can get up to the 23. Now, if we minus, subtract, we got 3 minus 1 is 2, 2 minus 2 is 0. Now we're going to bring down the 5. So now we have a 25 divided by 7. And we keep dividing down like that. So 25 divided by 7, the only number we can pick is 3 again, because 4 times 7 will be 28, which is bigger than 25, and we cannot subtract, so we have to use 3. 3 times 7 is 21. Take away 5 minus 1 is 4, and 2 minus 2 is 0. Now this is no problem. Everybody know how to do it, right? I just demonstrated because it will go to there related to the next step. So this number 4, if we continue divide, we keep dividing down, but let's say up to here we stop and we count, this is the remainder. Now the number we get answer on the top here, we call a quotient. And this number here, we call a dividend. And this number here, we call a divisor. Now, if I have to make a statement about this division, I'm going to write like this. 935 will be equal, the answer here, 133 multiplied with 7 and adding with the number 4 remainder. So obviously this statement, the left side will be equal to the right hand side. So the original number we divide, we call dividend. Here 935, we call a dividend. dividends will be divided by this two factor. When they time together, they add up equal this. If we have a remainder, we have to add to them. If we don't have remainder, let's say remainder 0, then this equivalent to this. So this now, I'm going to state this is the quotient. Multiply with 7 is divisor. Adding with 4 is remainder. Now, because when we write the statement like this, we're going to relate it to something we're gonna state the remainder theorem. Okay, so let now, based on this division, simple division, we're going to divide algebra expression here. And our first lesson will be based on the long division. We call it long division. So, long division. Long division. And our dividends here, I'm going to copy it down, is x to the power 3 minus 7x squared plus 11x plus 9. And we're going to divide with the factor x minus 4 with the divisor. So our divisor here is a whole bracket here. Okay, we raise a little bit so that now maybe I should erase this so we have more room. Okay, so the way we divide, we're going to divide exactly like the way we divide this number here. We're going to find the number or letter, multiply with this divisor equivalent to this first term. And that have to be an x squared. Because x squared times x will give us x to the power 3. X squared times minus 4 will give us minus 4x squared. Now we're going to subtract them. Just like we do it here. So x to the power 3 minus x to the power 3 equals 0. Keep in mind that this negative affects this negative. Because negative times negative is become positive. So I circle the positive here underneath below to show that our sign now will be considered as a positive value and not the negative 4x squared anymore, but it's a positive 4x squared. Because negative times negative become positive. So now we have a positive 4x squared. And the minus 7x squared, subtract the 4x squared will give us the minus 3x squared. So now I'm going to bring down the 11. So we'll add 11 down here. We bring it down, continue to divide. Find a number times with this equal this. Of course, the number will be 3x. However, I have to be careful about the sign. What sign should I write? Should I write minus 3x or should I write positive 3x? Now, by intuition, I know that I should write negative 3x, and I will explain to you about the sign. So let's multiply them first. 3x times 3x will give me minus 3x squared. 3x times minus 4 will give us plus 12x. So now I am going to, and sorry, I missed this x here, 11x. So now I'm going to subtract. And when I subtract, I will explain to you why I choose the sign here is negative. Because I realize this is negative sign. I should change this is the negative so that when I subtract, negative times negative will become a positive. And I know that if I have a positive 3x squared, add to the negative 3x squared, they both the same value, but the opposite side, it becomes 0. If I keep this one as positive, then I run into the problem that If this one is positive, then negative times positive will be negative. And then negative, add with a negative, it's like you add two negative values together. So it's not going to go away, it's not going to become zero. And that's the reason whenever I see the sign here negative, my sign here should be negative. So that's the way how I remember it. So negative 3x times x is minus 3x squared. Negative times negative, change this become positive, knowing that positive 3x squared subtract 3x squared will become 0x squared. And my total is going to turn this into 0 when I subtract, right? Okay, so now continue subtract this one. Negative times positive, right? This is a positive sign. So negative times positive will be negative. And this negative 12x adding with 11x will become negative 1x. So now I will bring down the number 9 down here and plus 9. So continue to divide just like we did here. So we will find the number or a letter multiply with this, we get exactly the same. So that have to be the, and keep in mind this negative. So I'm going to subtract again, negative 1. So 1 times x will give me 1x. Minus 1x actually, this is minus 1x. Minus 1x times minus 1x is minus 1x. Minus 1 times minus 4 will be plus 4. And I'm going to subtract between them. So keep in mind this negative affects this negative and this number become a positive. So we have a positive 1x adding to negative 1x is gone. It becomes 0. Now this negative, we change the sign become negative times positive become negative. So the second one is the one we pay attention, right? Because the affected by this negative. So the sign here is no longer positive 4, but it's negative 4. Negative 4 adding to positive 9, or 9 subtract negative 4 will be plus 5. So here is our remainder. And this answer will be a quotient. And this is a divisor. So now I'm going to write down the statement like this, right? In our division, I will say x to the power 3 minus 7x plus 11x plus 9 will be equal. The quotient multiplied with divisor, which is x squared minus 3x minus 1, let's put them in bracket, multiply with x minus 4, put in bracket, adding with 5. But remember this 5 have to be continued to divide by x minus 4. We not just stop like that, right? Yeah, for this number, when we add this, it becomes exactly like this number, right? So we don't have to do anything with this. But keep in mind that this number 5 still continue to divide by the x minus 4 here. Okay, so we have dividend exactly like this, equal the quotient time with divisor. I'm going to put in short form right now. Quotient time with divisor and adding with remainder. So that's the idea of the division, long division of the polynomial function. So I'm not just perform one example for you. I'm going to do the next example as well. So I'm going to show you how we'll divide one more time for the next example. So let me erase the expression for the question 2 here. So the question 2 say we have x to the power 3 minus 2x squared minus 15x minus 17. And we will divide it by the x plus 2. So this is the dividend divided by the divisor. Let's see what is the answer. So find a number times x equals x3. Obviously, it will be x squared. X squared times x will be x to the power 3. X squared times 2 will be plus 2x squared. Subtract between them. We have this becomes 0 minus 2. Now, keep in mind that this negative will affect the side, right? It's the same like you put outside the bracket, right? You have 2x squared minus plus 2x squared. Let's say you put side by side. Now, everybody know this will become, you remove this bracket, negative times positive will be negative. So negative 2x squared, negative 2x squared will be negative 4x squared, obviously. So we know this will be negative 4x squared. So even though you put in a column, the way you subtract the expression, exactly the same. You just have to notice this negative will change this positive become a negative side. And then therefore, I put down here and I circle that. So we pay attention to my circle here. Keep in mind this is negative 2x squared, no longer positive because it's affected by this side. So now the negative with the negative will become a negative 4 and x squared is x squared. So that's how we subtract the algebra. Okay, so now we're going to bring down the minus 15x down here. And minus 15x divided by x plus 2. We'll find a number times with x equal 4x squared. And because I have a negative sign, so I should put negative here. Negative 4x. So now I'm going to tie them together. Minus 4x times x is minus 4x squared. Minus 4x times 2 will be minus 8x. Subtract between them. Keep in mind this negative will alter this become a positive. So negative 4x squared plus 4x squared is 0x squared. This side will alter this become positive as well. So we have minus 15x plus 8x will become minus 7x. Now I'm going to bring down the minus 17 down here. Now I continue to divide. And of course the answer will be minus 7. Minus 7 times x will be minus 7x. Minus 7 times 2 will be minus 14. Subtract minus 7. This negative change the sign become positive. So we add a negative with a positive with the same value. Of course, the opposite side, they cancel out each other with 0x. This negative times negative will become positive 14. We have minus 17, subtract positive 14. So this lost 17 will win the gain 14. So we still lost, right? Minus 3. So I consider the way I subtract, I just say, I lost $17 because that's negative. But this negative change, this negative become positive. So I gain $14. If I lost $17 and I gained $14 at the end, I still lost $3 because this number winning this number. So I have minus 3. Keep in mind this minus 3 is a remainder. and I just put R for now. That's remainder. Let's put this polynomial into this statement. So I'm going to follow this. The dividend is this whole expression here. We write down x to the power 3 minus 2x squared minus 15x minus 17 will be equal, you see equal sign. The quotient here is the number go on top here. That is our quotient. So I'm going to copy this down. For the quotient, it will be x squared minus 4x minus 7. Time with our divisor, I'm going to put in bracket, the time together. Divisor here is this number, x plus 2, adding with the remainder. And our remainder is minus 3. So that is a remainder. So this go with this go with, sorry, this go with this, and this go with this. Okay, so this is our quotient, time with our divisor, which is this one here, adding with our remainder, the remainder is minus 3 down here. So I just replace the statement by this algebra expression. Keep in mind that this algebra expression actually we call a polynomial function. And why do we call this a polynomial function? Maybe I will explain this in another lesson. Actually, polynomial function is just the function like a binomial with the degree of 2. Sometimes we call a quadratic function. Sometimes it have a degree of 3, we call a cubic function, and could be a degree of 4 or 5 or 6, whatever. So polynomial function is just the function with on the variable of x or y, whatever we want to put in here. It's the variable of the letter with the degree, and the degree could be a power of 3, could be power of 4, could be a power of 2. We also say polynomial of the power of 2, we call a quadratic function. The polynomial of power of 3, we call a cubic function. The polynomial of power of 4, I remember probably we call a quadratic function. Up to degree 5 or degree 6, which is called a polynomial. That's it. So there's nothing new. It's just the way it explains it. So this is a polynomial function. Now, in this lesson today, I'm going to talk about the remainder theorem. So what is the remainder theorem? Let's write down. So I'm going to make a statement here. The remainder theorem say, the remainder theorem say, if we have a polynomial function p of x, right? Just like the dividend here, but that is a polynomial function. This polynomial function have a highest degree of 3. If polynomial function divided by a factor x plus 2, divided by this factor. So if this, then this, arrow, p of 2, p of minus 2 equal minus 3, which is equal the remainder. So basically, this statement helps us to reduce our work. Let's say if the question asks you, if I have a polynomial function like this, and I divide by this, assume that you close your eye and you don't do anything, you're lazy, you're not doing anything, right? My question to you is, do you know what is the remainder if you divide them? Without divide. So that is the remainder theorem mean. This remainder theorem helps us to do math in a lazy way. Let's say if they say, I have a polynomial function, blah, blah, blah. I want to divide by this factor, blah, blah, blah. Without the division, answer me with the short answer. Do you know what is the remainder? So if you don't divide, how do you figure out the remainder is minus 3? All what you do is using the remainder theorem. And that is the purpose. So first of all, let me test this theorem first. Let me test if this theorem is correct or not before I will explain it how and why it's correct, right? And what does it mean? So let's test it. The remainder theorem say if this, then this. So let's test. Does this statement is true? So I'm going to test, right? I'm going to say, okay, pretend that I'm not going to go through the whole division like this. So let's say I don't have to divide like this one, okay, to get the remainder. Let ignore this for now, okay? I'm going to test to see if I substitute the p of x equal p of minus 2 in here. Does this calculate it out and equal minus 3? So let me test this statement first, right? So the polynomial is this one. Is this one, right? So maybe I need the board. I don't want to look so messy. So let me erase this one, okay, for now. Let me erase this. Just remember that we go through a whole long division, right, to get the remainder, right? Get the remainder of minus 3 here, right? This is our remainder, right? Our remainder. So, but we have to divide to get there, right? So let's say that if we lazy, we don't want to do division, long division. We are going to test if the statement is true. So the polynomial function, I'm going to write out our polynomial function in here. And our polynomial function is number 2. We want to focus on number 2, right? Let's ignore number 1 here. And let's focus on number 2. So our polynomial function is number 2. So I'm going to write the polynomial function here. So p of x is x to the power 3 minus 2x squared minus 15x minus 17. Now, we're going to substitute the x by minus 2 because that is statement told us, right? P of minus 2. So p of x here become p of minus 2. It means that we can substitute the minus 2 for x, follow our expression, and calculate it out to see if we get the remainder. And that a lot quicker than we have to divide, right? So minus 2, I'm going to put in here minus 2, power 3, follow expression, right? Minus 2 times minus 2 square. I just follow that. Minus 15 is minus 15. X is substituted by minus 2 and minus 17. So let's calculate what is p of minus 2 equal. Minus 2 to the power 3 is minus 8. Minus 2 to the power 2 is positive 4. Positive 4 times minus 2 is minus 8 again. Minus 15 times minus 2 is plus 30. And copy the 17 down. Now let's calculate. Do I miss anything? Doesn't look like it, right? Okay. So now all of this number is negative. I'm going to add the total negative together, right? And my total and negative together, A and A is 16. 16 and 17 is 33. So I have minus the sum of minus 33. The sum of the total negative number equal minus 33 at 30. Minus 33 at 30, of course, equal minus 3. So yes, the theorem is true. Without dividing, without using the long division, I be able to substitute the minus 2 in this polynomial function and calculate it out, and I get the remainder. So let's say you trick me, you say, I give you a polynomial like that, I give you a factor like this, right? Or a divisor like that. My question to you is, how do you calculate the remainder theorem? This is what you do. You just substitute P of x equal minus 2 into the expression, calculate it out, you get the remainder number without going through the long division process. And that's my purpose of the lesson today, right? So I do perform 3 of the objectives here in this video for you. First, to show you how to use the long division, divide the algebraic expression by example 1 and example 2. Then I relate it to the state of remainder theorem, which is here, and I prove this statement is true. Are you happy with my video? Probably maybe 80% happy, right? What is 20% left you're not happy about? I haven't explained to you why. Why the remainder theorem like that, and it's true. It's say like that, and we test it and we find it's true. But how do we understand about this, and why it happened like this? It's like magical, and like magic. Without the calculation, we can get it very short time to get down to the answer, right? So let me explain the meaning of it, the concept of it, so that I can earn 100% trust from you, from my audience. Okay, so everybody knows this statement is true, right? If we have a dividend and we divide and we get the answer, that answer we call a quotient times with the factor here, which is divisor. So dividend equal the quotient times divisor plus the remainder. So basically, this polynomial function equivalent to this 2 factor in here. One is the factor here is the answer we got, the quotient on top, right? And the divisor, which is divisor here, is also one of the factor. Now, when you can express this expression into 2 brackets like this. Each bracket here we call a factor of this polynomial function. So in this polynomial function, we have 2 factors here, typing together, adding with the remainder, it will give us the equivalent of our polynomial. And this is a polynomial. So one of the factor of this polynomial is x plus 2. One of them, right? The other one is x squared minus 4x minus 7. If we set this equal 0, if we set x plus 2 equals 0, and we solve for the value of x, we move this over, x equal minus 2. So now you know that this minus 2 here, can substitute by x. So P of x, if we substitute the minus 2 in here, right? Now let's think about it. Why do we substitute the minus 2 in this expression? Basically, the same like we substitute minus 2 in this bracket, right? and in this bracket, the same like we substitute this -2 in here. The same like we take the -2, we substitute in here. And what happened? If you substitute this -2 in here, you calculate it out. This is what we did here. And you substitute the x here -2 plus 2. What happened? -2 and plus 2 is 0, isn't it? So the 0 times with anything is equal to 0 as well. So the whole thing become a 0. And we left with -3. We left with the remainder. So that's true. That's obviously we see it here. If you substitute the -2 in here, right? -2 plus 2 equals 0. 0 times with anything, this bracket here, any number, regardless what it is. 0 times with this bracket will become 0. And of course, we end up with the remainder theorem. We end up with the remainder number, which is -3 right here. So actually, that's how it works. You just substitute one of the factor into this one, then you will left with the remainder. Now, whether you substitute in these two brackets and you tie them together, or you substitute in here and you calculate it out, this is exactly the same because this equals this plus this. So now if you substitute -2 in here, you get 0 times with anything is 0, you're left with this remainder. And we take advantage of the concept here, we make a statement of the remainder theorem. So given you a polynomial function and a divisor, which is this, let's say if we don't have to figure out the answer, the quotient. Let's say we don't go through the long divisor, right? What we ended up with, we ended up with the remainder. So it means if we substitute this number in here, we got the remainder without doing the calculation. Without doing the division, long division. So that is the remainder theorem about. I hope in this video, I give you 3 objectives. I hope that I achieve the 3 objectives from this video. And I hope you enjoy the video here. Keep in mind, this is pre-calculus math 12, right? So we require a little bit of conceptual thinking. And if you, my audience, you jump in the middle of my lesson online here, without following my course online, right? Because this lesson put in my math course -online.teachable.com. You follow me with the right level, math 12 with calculus, and you follow me from the beginning to the next step, you will understand this no problem. But if you jump in like you're watching on YouTube, and maybe a lot of you will be able to catch up and understand it well. A lot of you might have a better strategy than the way I explain. And maybe a lot of my audience will say, what's she talking about? I don't get what she was talking about. Which is I accept it because I'm here teaching like on the YouTube, right? Not in my classroom. So, however, I wish that my video still be very useful to some of the audience. And please give me a subscribe and hit like if you like my video. Thank you for watching and bye for now.